So we discussed a little about a general econometric model approach, and here let's look at a specific model called econometric models based on panel analysis. Again, I'm not an expert, so you'll have to read up more all these papers that are cited here. Econometric models based on panel analysis identify the effect of weather shocks on changes of GDP per capita using either fixed effects or first differences. Impacts of warming are projected using short-term elasticities, so that's how the economic elasticity is going to be involved here, without accounting for adaptation that relies on stocks. So this is a detail here that you have to look up. To identify the effect of weather, these methods focus their attention on the impact of unexpected shocks over short periods of time, and are therefore unable to capture adaptation benefits that take time to unfold. When you make adaptation hard and soft measures for adaptation, there is a time scale over which they serve their purpose and their benefits become evident, but these short-term simulations or calculations do not account for those benefits. The slow adjustment of capital makes impacts from unexpected deviations of weather from normal conditions different from slow-moving climate change. So slow-moving changes in rainfall and temperature are going to be different than, a heavy rainfall season or a heavy drought season and so on. Inferring climate change impacts from unexpected shocks implies that short-term imperfections are permanent. So you have to be careful in interpreting the model outcome in this case. For example, as heat extremes become more frequent, we may see more increased mortality from the heat stress in households in areas where mild temperatures have not simulated the adoption or air conditioning. But as it becomes clear that the temperature distribution has shifted, that's a slow change, it's reasonable to expect that air conditioning will be adopted and mortality will converge to that in areas that today already have air conditioning. So there are other issues about air conditioning's impact on climate, but that's not what we are talking about here. Projecting mortality at the end of the century using elasticities estimated using weather shocks implies that air conditioning or any other adaptation will never be adopted over the next 80 years. So obviously econometric models cannot be used for long-term simulations or computations or projections. We have to rely on IAMs for that. For this reason, this literature is generally not used to estimate economic benefit of adaptation, with some exceptions. Some studies compare the effect of weather shocks in different climates or over time to learn if weather shocks have different impacts in different climates, a result that can be interpreted as the evidence of adaptation. So this paper by Khan and others measure weather shocks relative to a trailing moving average of weather. It just depends on how you are interpreting low frequency changes. With this method, the authors estimate that adaptation has the potential to halve the long-term cost of warming. It's good news, but again, you have to be sure what the assumptions are and compare maybe with other projections or the time scales, same time scales with maybe IAMs and so on. Estimates of climate change damages. So we looked at figure 1 in the main text, which displayed estimates of global climate change damages from a comprehensive review of the literature. The full list of studies is available in a table that I won't go through. Estimating the cost of climate change is a complex exercise with many sources of uncertainty. So people try valiantly to estimate the damages from global warming in the range of 1.5 degrees to 2.5 degrees C, corresponding to scenarios shared socioeconomic pathway 1, 2.6, which could lead to median loss of 1.5%, but a range of -13 to +1, so you +0.1. So you can see uncertainty can be very range in terms of annual GDP by 2100 with respect to its reference level without climate change. So again, counterfactual versus pathway with no action, and so on. These ranges reflect the status of the literature but do not span all possible future outcomes because of the inherent limitation of studies. So the key summary is that estimating climate change damages is still not a trivial task. How is it possible to reconcile estimated average costs that can seem rather small with the large concern expressed by scientists and the international community? There are two issues here. The climate scientists are going gangbusters on warning humanity about the future and the potential dangers of climate change, and some mitigation needed mostly, but also adaptation. And then there is the concern of the governments, and then what can be estimated in terms of economic simulation models and econometric models in terms of damages. How do you reconcile those? The answer is that these studies may substantially underestimate the global cost of climate change in several ways, and that global averages do not reveal the unequal distribution of climate change impacts, which imply devastating impact of small vulnerable countries. So many really tricky things to worry about here. I won't read all these details, but the costs presented in figure 1 are global averages that hide large negative effects in developing countries that are already hot in small vulnerable nations, as shown in the academic literature cited here and in several IMF studies cited here. We already discussed this a little bit. Global average costs are also attenuated by potential gains in some colder countries in some studies. So warming is not always bad. So if Siberia warms up, becomes suitable for growing wheat, it may become the breadbasket for the world, for example. Within countries, disadvantaged sectors of the population will suffer larger welfare losses. These uneven effects of climate change are of great concern for economic and ethical reasons, and because they could push some countries to unsustainable fiscal territory and may lead to global macro instability. Always comes back to who can afford to adapt, who cannot, and what happens when those who cannot adapt go into these so-called unsustainable fiscal territory in terms of the impact on global markets, global GDP, global macro stability, and so on. Some studies that use IAMs include damages from only some climate catastrophes and losses enter as expected values. Econometric studies only consider temperature and sometimes precipitation. This means that worst case scenarios are missing in the figure that we saw. Some studies that we do not include in our review because they cannot be easily compared. Simulated costs crossing tipping points and other damages can be substantially large, but there is large uncertainty in the literature. So just remember that estimating climate change damage is very tricky and very uncertain. How to take action based on this uncertain information, especially in terms of investing in adaptation with limited room in the budget, is always very, very challenging. Politicians have to make decisions. Scientists can give advice and not be responsible for decisions, so we have to remember that as well. Non-market impacts are critical in terms of climate damages, so they are imperfectly included in some of the IMs. None of the studies surveyed in figure 1 consider the possibility of crossing societal tipping points triggered by climate change, such as social conflicts, wars, disruptive migration flows, because empirical data to quantify these risks is lacking. Should we say something about it nonetheless? In the physical climate world, there are people who are heuristically deriving tipping point, estimates in terms of how close we are to a tipping point, choosing a a range of tipping points. But not everybody is a fan of this approach of taking models which are not doing tipping points and then empirically and heuristically saying we are too close to a tipping point, that we are underestimating how close we are to a tipping point, and so on. These are sometimes not completely careful about the consequences of such claims. Finally, GDP only measures economic output and is at best a partial measure of welfare. We already know that. It does not reflect the welfare losses resulting from channels more resources for investment away. Again, reading it with different emphasis. It does not reflect the welfare losses resulting from channeling more resources for investment away from consumption, as would be needed if post-disaster reconstruction needs become more frequent. GDP losses also underestimate welfare losses when consumption losses are concentrated on certain groups, on poorer people, as is expected with climate change. So there are normative, ethical, moral hazard questions which all have to be kept in mind. So let me leave this here and come back and maybe wrap up with the Annex 2 on costs of making infrastructure more resilient, which is a good example of not only adaptation needs but also integrating adaptation to climate change in fiscal policies and worrying about the macro fiscal issues associated with that integration. Okay?